Hello everyone, I'm Erwin Quiring, and my talk is about the manipulation of a reviewer assignment system that is used by conferences. Initially, the plan was that Thorsten Eisenhofer will present the talk, but he's not feeling well, so I'm here. So peer review is a major part of academic research and the scientific publication process. And despite the well-known weaknesses and problems we have, it's still a very important instrument to ensure high quality standards in the papers. So in the initial step, there's an assignment so that papers are assigned to reviewers, so that the papers match with the qualified reviewers. And although that's, so this happens by, for example, bidding. So reviewers would bid on the papers they want to review, and then they got assigned to the reviews, to the papers they want to do. But there is a problem, and that is the number of submissions is increasing considerably in the last years. Just take NeurIPS, that now has over 10,000 submissions. If you spend just your time reading the paper titles, which takes about 3 seconds, to read all submissions, you would have to spend 8 hours to go through all paper titles, only paper titles. So the manual bidding is not possible anymore for these large-scale conferences. So conferences like NeurIPS, ICML, or even CCS in some years have adopted automatic solutions for the assignment. In a nutshell, you have some reviewers, you have some papers, you just feed them to an assignment system, and at the end you get an assignment. The paper is reviewed by the best matching reviewers. And of course, machine learning is used to do this assignment. Now, topic modeling is the key to this paper reviewer assignment. And let's go into some details of this process. So first, we have a corpus of paper documents, ideally from the different reviewers that are in the program committee. Now we cannot directly apply machine learning on this corpus, on the PDFs directly, right? So to work as machine learning is working in the feature space, we need to do some prior steps. And this includes, in the first step, this is a pre-processing. We first extract some text out of the PDFs, and then apply some NLP tasks like stop word removal, tokenization, stemming, and so on, so usual NLP tasks. And then we apply a feature extractor that maps the input to a bag of words vector. And in this here, we can see an example. In this bag of words vector, every dimension is associated with a word. And if the word attack is present in a document, for example, 61 times, then this dimension with the word attack would have a value 61. So that's a simple bag of words vector. Now, in topic modeling, we then go over the different documents, and we then use a topic extractor to arrive in a topic space. In the topic space, every dimension reflects a topic, and for example, here, the first dimension would be somehow something about crypto, where crypto and key characterizes this dimension. Then we have in the second dimension the topic code analysis, and the third dimension something about machine learning security. And then this defines this topic space, and we map all the documents from the feature space, these bag of words vectors, to this topic space. And then we can see, okay, this one document, one paper submission is a topic mixture of, for example, attack models, so adversarial machine learning security, and code analysis. Now, recall that we want to assign reviewers to papers. So we first need to understand in which topics a reviewer is working. So what we do is we take a set of prior works from every reviewer, take their union, and just repeat the process I've described earlier. So we extract from the whole set of the papers the bag of words vector, and then apply the topic extractor, And then we arrive in this topic space. And here, just an example, we have, again, a reviewer who has a topic mixture of 70% machine learning security and a little bit code analysis. Then we have other reviewers that are a little bit in other areas of the space. And now to assign the submission, a current submission at the conference to the reviewers, we just also repeat again this process, arrive at a topic mixture in this topic space, and then we can just compute the dot product, the similarity between the submission vector and the reviewer vectors. And here we see that the yellow reviewer below is very close to the submission, so the topics match, and this reviewer would, in the ranking of the reviewers who get assigned to the submission, this reviewer would be the highest one, and then the other reviewers are following. Now, we were interested in the security of this whole automatic reviewer paper assignment system, and the goal is here to manipulate the submission, only the submission, to pick the own reviewers, to, for instance, to select a reviewer, so we want to go in the space towards our target reviewer, or to avoid some reviewers, so we want to reject a reviewer. We all know reviewer 2 who gives bad reviews, so what if we just could just change the submission to avoid this one reviewer and we don't get that reviewer, right? And that is the goal of the tag. So we move into the space. And that's not that easy in this topic space because we don't have a gradient that is guiding us. And there's another problem, we still have to manipulate the submission, right? We cannot just do something in this topic space and have a topic mixture as target, we still need to manipulate the submission. So we need to work also in the problem space. And we did that. We defined different transformations to add and remove words from an input submission. We had a hidden box, so we just, this hidden box allows an attacker to add an arbitrary number of words that are extracted by the PDF to text tool, but are not visible by the PDF viewer. So we really exploit these problems with all these PDF and format issues. Then we had homoglyphs that are just similar looking characters. So the Latin A looks very similar to the Cyrillic A, so you can exploit that. We also had text level transformations, like we would add, suppose you want to add the word Einstein to your paper. Then you can also take just some papers from him and to add them to the bibliography. We also used language models where we instructed them to add the words we wanted to have. And we fine-tuned these language models on security papers, so really we got really good looking security text, security paper text. Then we can chain these transformations together, and in this way we get can realize different attacks. But we have constraints. The review process is very picky, right? So the for attacks, the transformations need to be plausible and semantically correct. We can add a few spelling mistakes, but we cannot add 2,000 spelling mistakes. Then the paper would directly get rejected. And then we implement a hybrid search strategy. So we work with a submission, we are in the problem space, we map it in the feature space. Here we do some search to find a good manipulation vector, so we can find out which words have to be added or removed by constantly asking the assignment system for the ranking of the reviewers. Then we find a good solution. We map it back to the problem space. We instruct the problem space, please add these words or remove these words. We do that, and then we map it back to the feature space, but probably we won't end up at the same position we wanted to have because we have side effects. Think about adding Einstein. We will probably also have to add a paper title, of course, in the references, right? So you have added more words that you actually wanted to have. So you have side effects, and this swapping between, with switching between the spaces allows to compensate for these side effects. And in the end, we we map it back to the problem space, and we get our adversarial submission. Just as an appetizer for our very comprehensive evaluation, here an experiment where we simulated the S&P 2020, and here you can see the success rate as a ratio of how often could we manipulate the reviewer ranking, depending on the number of the switches where we switch between the problem and the feature space. And if we use all transformations, and in particular the format level, that allow you to add arbitrary changes, because as I said, the comment box is not visible, you can add an arbitrary number of words, then we arrive at a success rate of close to 80%. With more switches, the success rate is increasing, so we really see that our hybrid search strategy is necessary and very beneficial to increase the success rate. Then we looked if we can achieve a similar success rate when we just apply, for example, text level transformations. So text level are really only visible transformations to the PDF submission, like adding text, adding references, some spelling mistakes, right? And it's interesting, we can get almost 50 or around 50% of success rate just by using text changes to control the reviewer assignment to some part. More results are in the paper. In the paper, we implemented a white box scenario where the attacker had control over or knew the whole assignment system, but we also had a realistic black box scenario where we assumed that the attacker is really just an author of a submission, knows the website of the conference, knows the number of the PC members, would crawl their Google Scholar profiles, would train an own paper review assignment system, which probably will not match with the real one. So we really did different experiments to find out how well an attacker could control the review assignment in this scenario. And it turns out it is possible. So in summary, our work is, we showed that the automatic reviewer paper assignment is vulnerable to attacks, to adversarial papers. And before we implement these, or if we implement these solutions, we really have to be careful because academic misconduct is happening, and we need to be careful to avoid that this reviewer assignment is manipulated. In a more general terms, we implemented a new hybrid search strategy to switch between the feature and problem space, which is usable for adversarial learning, even not just for this scenario, but in general for discrete domains like text, source code, and so on. And yeah, in a broader perspective, of course, we still need to deal with this adversarial machine learning scenario that we need to make learning models and machine learning secure. If you're interested, check out the artifact. The code is publicly available, can be reproduced. And yeah, thank you so much for your attention, and happy to answer any questions. Thank you.